Hello everybody, welcome to another video lesson. Today we're taking a look at evaluating published data. We're going to see if conclusions drawn in published reports are valid, and we're going to take a look at how to identify misleading data. So hopping into it, let's take a look at evaluating reports. Okay, I always want to think first who evaluated or who reported this data, who published the report, and what's the relationship to the industry or to the study that the industry took place in. And how could that affect their intentions when publishing this report? So we have a bunch of questions we want to ask here. So make sure you're writing down the questions on the right-hand side. First thing, what was the survey size, the sample size, and was it based on a random sample? So in this example, we have a cafeteria at a hospital that offers a bowl of fresh fruit and other items for dessert. Now, researchers tracked 200 hospital employees who eat lunch at the cafeteria, and they divided the employees into two groups. Those who chose fresh fruit for dessert and those who chose other items for dessert. So cookies, cakes, stuff like that, other sweets. So we have 200 employees. That's a pretty good sample size. Is it a random sample? Well, in the context of lowering blood pressure, maybe not, right? Like if this is only people who work at this specific hospital, you probably want a little bit more diversity within your sample size. Now, could there be bias introduced into while conducting this survey? Well, that kind of goes into why are we only looking at this one hospital? Can't we look at other, a more broad range of people here and have a little bit more of a random sample that's going to help us reduce that bias? Now, was this study based on a controlled experiment? Well, we do have two groups here, which often we think we have two groups. Well, that looks like an experiment, right? However, these people aren't being affected by this survey at all, or by this study. There's no control group versus experiment group. They're just looking at people who choose fruit for dessert and those who choose other items for dessert. Okay, so in this case, we actually don't have an experiment. And can a cause and effect relationship be deduced from our data? Here, this study concludes that those who chose fresh fruit had lower average blood pressure than those who chose other items like sweets. But that doesn't necessarily mean that eating fruit lowers your blood pressure. In fact, the people who worked at this hospital and ate fruit for dessert, they could have had other lifestyle habits. So you can't really make a cause and effect relationship here just by this information. Okay, taking a look at identifying misleading data. We want to always look at the graphics within the reports. That's usually where a lot of the misleading information is going to come from. So we have another list of questions here that we want to be asking ourselves. First one, do the scales of our axes begin at 0? And if not, is it shown is a break shown on the axes? So we see here our scale does not start at 0 and we have no break shown in our axes. So if you have a scale that is not starting at 0, then you want to show that with a little break here. Okay, that's going to tell your audience that we are not starting at 0. That's going to give them that indication there. And then you would just start at whatever your first number is here. It would be 8,500. But we don't have that here. Now, do the axes use consistent intervals between tick marks? Well, they do on the vertical axis, but on our horizontal axis, we see that our last month jumps from April to July. And so we now have inconsistent scale throughout the graph here. And then if we have a histogram, is it grouping the data appropriately? Are all of my columns the same width? And if so, are they appropriate width for the data set that I'm given? Now, does the scale distort the difference in data values? Now, in this case, it actually does, because this looks like this social media person has a lot more subscribers from January to 5 months later, when in fact, they really started at 8,500 and only ended at 8,900. So it looks like there's a lot more growth than there actually is if you think about the percentage of that growth. All right, let's hop into our examples here. Explain whether the conclusion in the report is valid. So researchers tracked 350 randomly selected adults for 1 year. So 350 is our sample size. The participants were divided into two groups, those who work in a garden at least once a month and those who do not. So we can see here we have a pretty good sample size. However, we are not dealing again with an experiment. We have two groups of people, but we're not making them do anything. We're just watching them as they either garden or don't garden. So we're working with an observational study here, which means it's probably going to be pretty hard to draw a cause and effect conclusion with whatever we're doing. So at the end of 1 year, participants are given a blood test, and researchers found that the gardeners had healthier cholesterol levels than the non-gardeners. Okay, so clearly this is stating clearly that gardening is good for achieving healthy cholesterol levels. Now, think about the past example in our concept slide. There could be other reasons why you have lower cholesterol. For instance, gardeners could be more likely to eat the fresh fruit and vegetables from their gardens, and so that could have more an effect on their cholesterol than the act of gardening itself. So we would say that this report, actually the conclusion within this report, is not quite valid. All right, identifying misleading data. We're going to explain whether we have misleading data here presented to us. Okay, so we have donations. We have 10 randomly sampled donations received from the Gray Foundation, shown that most donations in the charity are in the range of $41 to $60. Now the histogram displays the data here, and we have the data set below. Okay, this is 42, 21, and so on. So first things first, we see that our axes do start at 0, so that's a good start. And really our histogram is accurate. If I take my data set and I put it in order from least to greatest, we can see that my histogram is in fact accurate. However, the groupings on our horizontal axis are actually quite misleading, because we don't, like, where does this $60 figure come from? It really looks like a lot of donations are up around that $60 range, when in fact our maximum donation amount is only $43. So this is just one example of some misleading data that you need to watch out for, guys. But that is it for this video, so good luck with your practice.